Hey folks, I'm Chuck Black. We're doing 52 weeks of Python. We are in week number 60, and we're actually talking about denial of service type stuff. And so I really don't want to teach you to become a denial of service person, but what I do want you to become aware of is what denial of service is and how you could create something similar using Python. Remember, the main goal here is not to give you tools to be mischievous, but rather to teach you to become a Python developer and a real legitimate software developer. And maybe in the future, if your boss says, gee, wouldn't it be nice if we could do this type of stress testing of our product or our switches or something like that, you can say, hey, I know how to do that. And so that's what we're going to be talking about. You can see in this picture here that this is my denial of service code architecture. So we will be talking about creating threads to do denial of service. We'll talk about HTTP and Icmp, which I have implemented. We'll look at the code that actually does it. We will actually also look at code that causes our quokka-prime application to be able to throttle requests and turn them back at the entry point to our application. So there's something called Flask limiter that will allow us to do that. And we'll look at the differences in different systems. We'll be looking at attacks to and from my other laptop, which is running Ubuntu natively, and it has 8 cores and runs quite fast. So it is able to attack this device that we're looking at, that I do most of my software development and video development on, and it is this other system, this other laptop is way more powerful, so it can attack this system effectively. This system is pretty puny and insignificant, and so when I try to do denial of service attacks to this other more powerful system, it doesn't work. But anyway, we'll see that in some of the examples that I give, and then we'll look through the code, both the code that I wrote to do the denial of service and the code that I wrote to limit denial of service attacks. So without further ado, let's get started. Okay, I'm just showing you some Git stuff here. So as you can see, I have my module 15, which is where I'm experimenting with denial of service stuff. I have already done denial of service HTTP, denial of service ping. Those had a lot of repeated code, and so I decided it would be a good idea to go ahead and create denial of service, which includes both, as you can see here, ping host as well as HTTP requests. So I've done this code down here just the one time with a couple of minor changes, and I'm able to reuse this nicely. So what I need to do is I want to make it available on my other system, because as you will see, or maybe you have seen, I'm not sure the order, but I'm going to be running some of this code from a different laptop that actually is better performing. So I'm going to go and open up a window here. I'm going to change directory to Python 52 weeks, which is where I keep my stuff. And from here I can say git status. And as you can see, I have a new file, my M15 denial of service. Actually, that is, this is my file right here, my dos.py. And you see that I've modified both dos.py and dos.http. So what I'm going to do is I'm going to say git commit -am adding dos.py general module. So I'm going to do that. Then I'm going to say git push origin main. Main is the branch that I'm on. I'm not doing any special branching. And now I have saved it up into the cloud in my Git repository. That means that I can then pull it down from my other system. Okay, so here I am running on my other laptop. You can see that it's a different laptop. I have all the extra cores. So yeah, and I have stored, I've done a git push to store all of my changes to the cloud. I don't have those changes here, so I'm just going to do a git pull. And when I do a git pull, it's going to pull down the objects from the cloud, and as you can see, dos.py, there was a lot of changes. Basically the entire file is new, and there were 3 lines changed in DOS HTTP. So now I have the new stuff. So this is just an example of how I use git push from my other system and git pull from this one in order to keep my software up to date on both machines. So hey, the next thing we're going to be doing is looking at 3 different scenarios. I have 2 laptops, one on which I'm running all of this stuff that you see here, and another one that actually is running Ubuntu natively, and it has many cores and is very powerful. And the goal of these is not to demonstrate one laptop destroying the other, but just to show how denial of service works, and for us to take a minute and understand exactly what the attacker is doing and the ramifications that are on the one that is being attacked. So really don't look at these to be completely destructive, and don't be disappointed if one doesn't destroy the others. It's really looking at what is the effect of this type of attack, and then we'll look at the code afterwards and see how it does what it did, and then also towards the end we'll look at ways to limit the damage of an attack. So yeah, that's what these next 3 scenarios are all about. Okay, in this scenario I'm going to be doing a denial of service attack from my VM running on my laptop, which is not terribly powerful, towards this target, which is a laptop that's running Ubuntu natively on it, and it has 8 different cores, and it's a pretty powerful system. So I'm going to go ahead and start Quacka from quokka-prime here running, and now I'm going to go over to my other system, and I am going to start the actual attack. You can see that I've got, I'm running dos.py. My target is this particular system that I'm looking at. It's .34, and I'm getting hosts, so I'm getting all hosts. And you can see it's making HTTP requests. My HTTP requests are being successful over on my laptop that's running Ubuntu natively. You can barely see an impact, even though it's hammering it as hard as it can. It has actually gone up a little bit, but really not too much. You can see down here that the amount of networking stuff going on is a little bit more. On my other laptop, on the VM, you can see that the networking stuff has gone up significantly, and on the system that I'm doing the denial of service attack, I've practically denied anything to run on my system because it is actually running so hard. So my attack system is actually the one that's getting hammered, and back here on my laptop that's running Ubuntu natively, it's not really feeling too much of effect. But you can see this is in general what a denial of service attack is. As you can imagine, if we were to turn the tables and have a more powerful system trying to attack a less powerful system, or if I had more of these applications going, maybe on different systems, even doing a distributed denial of service attack, that would be more effective. Okay, so in this scenario, I'm running from my laptop, my powerful laptop, and I'm going to attack the VM on which I do most of my work. So I'm going to go to this other VM, and I'm going to run Quacka. So it is now running on that VM. And now from this laptop at which I'm sitting right now, you can see I'm setting my pool size to 200. So I'm starting 200 threads. My target is this system that I'm running Quacka on, and it's an HTTP type attack. You can see my CPU utilization on this laptop as well as over on the VM are reasonably low. So let me go ahead and start this. And you can see that my requests are running. They are successful. So the Quacka server is able to keep up on this Asus laptop system on which I'm running. You can see a incremental increase in CPU utilization, but it's not getting hammered too hard. It's still on average under 20%. On the other hand, over on my VM that is running Quacka, you can see that the CPU utilization is up around 80%. That may be as high as it can go. I'm not entirely sure, but you can see it's gone from very low, under 10%, up to 80% because of all these requests that I'm making. You can also see that the amount of megabits per second in the network history in both situations has gone up significantly. So this would be an effective denial of service attack, especially if you were able to get multiple of these systems doing the attack all at once. Now I also have an Icmp or ping attack that I have created that does similar things. It creates threads which go out and do the dirty work of doing Icmp or HTTP or whatever it might be. And so that's what I'm going to show you and demonstrate right now on my VM, the less powerful machine. I'm not running Quacka because it's not required. I'm just sitting there doing basically nothing. And on this system, I am going to be running my DOS denial of service application. Again, my pool size is 200. My target this time is just the IP address. Notice I don't need any of the HTTP or any other stuff. In fact, it wouldn't work if I gave it. That's my target is an IP address, and my attack I'm saying is Icmp. That's a ping. So I'm going to run that, and we'll take a look at what happens on this system and what happens on the other system. So you can see it's doing all of these pings, working very hard, doing a ton of them every second. You can see my CPU utilization is going up more than it was before. My speculation about why that is because the responses to the pings are so fast, it's keeping my system very, very busy responding to these things. So it's still only up around 35% most of the time, but still we're probably per second doing a lot more pings than I was doing HTTP requests per second, and that's my speculation as to why this CPU has gone up. On my other system, you can see that basically nothing has happened CPU-wise, but over here, the network history has gone way up. So the network history has increased to where it was before, and you can see that there's about the same size sending and receiving, but the CPU is not getting hammered at all. Why is that? That's because all of the lower level networking functions, like responding to a ping, are done at the lower levels, whereas before with HTTP requests, the requests were coming all the way in to my Quacka Flask server. Not only that, but I was going out to the database to respond to this host's request. So yeah, there you see the Icmp attack from this denial of service stuff that I've created. Okay, so let's talk about this denial of service thing that I created, bearing in mind that my goal when I did this was not to create a great denial of service application, but rather to demonstrate techniques that you might use to create a denial of service type application, as well as creating something that would be useful for doing, say, stress testing, etc. And it's really to exercise your Python skills more than anything else. So this picture kind of describes what I've done. It is a very small amount of code. The main application basically creates some number of threads. That's the pool size parameter that we pass in. We pass in the target to the application, and then that target is going to be sent to every thread that we create. So we're using threads in order to do this. I'm using a thread pool specifically, and I'm creating it with passing of a parameter, which is the target. And then all it does is it loops forever as fast as possible, sending requests to the target. And the more threads that you create and the more capacity you have on your application, on your system, to handle many threads, so the more cores you have and the more processing power you have, then the better you'll be able to do at stress testing or doing a denial of service type of attack on a target service or a host. So the more power that you have over here, obviously the better. Now, one thing to bear in mind, I want you to be aware, we talked in the last lesson about when we were trying to crack passwords, we talked about concurrency versus parallelism. And if you need to, you can remind yourself of what that is all about from the last lesson. I also talk about it when I talk about threading and async IO and things of that nature. We can use threads. The reason that we can use threads is most of our time is spent waiting for this request to be satisfied, whether we're doing a ping Icmp or whether we're doing an HTTP request. Those are the only two that I've implemented, but we will be spending most of our time waiting for the reply, and since it is therefore IO bound, using threads is a very good solution. If we were doing something like cracking a password, then that would be something that if we're just doing like a brute force method, then we need to use the cores of our system and to do parallelism. But we're not doing that this time. We're doing concurrency and using threads in order to do that. So that is what we're doing. That's the pictorial view of what it is. Let's look at the code itself. So here we go, looking at the code itself. This is the application that I built. Now, I initially created an HTTP and a ping version of this. When I was done with that, I realized that too much of the code, or a lot of the code, I guess not too much, but much of the code was replicated in those two applications. And if I was to build, let's say, 7 more denial of service application functions, then I would be recreating that every time. And every time I made a change to that common code, then I would most likely need to change it in all of those modules. And therefore, I created just the one. So there is only one that you need to be concerned with, and that is dos.py. And that's what we're looking at here. I am using a sub-process, that's to do the ping. I'm using requests, that's to do HTTP. I'm using argparse, that is to get the parameters that are passed in when the user runs our application. The parameters would be, as you see here, pool size, target, delay. That's if you want to not constantly loop over and over and over again, but have a small delay in there. It defaults to 0. And then attack, which is what is the attack type. That will be HTTP or Icmp at the moment. Concurrent.futures, that's where we're doing our thread pool. And then we have some sleep stuff and date time. That's about it for just kind of utility printing stuff out. And pausing, here's where I get my arguments. We've seen this before, no need to go over this again. I will point out that I do create my actual, the parameter for the attack that I'm looking for is going to be Icmp or HTTP. I realize right now I'm not really doing anything fancy with it. I probably should do a dot lower to lowercase it, or dot upper probably, because I stored it in uppercase. In fact, why don't I do that right now? In fact, I probably should just change it. What I should do is I'll change it right here, and I'll say args.attack.upper. And assuming that I did that correctly, then things should be satisfactory. Apparently, I don't need these parentheses, and I'll get rid of them. Hopefully that will work fine. I will change this if it doesn't. Anyway, I'm uppercasing it. I've stored it in uppercase, and I do future comparisons uppercase. That's why I needed to do it here. I was contemplating doing it here, but if you will notice when I come down here, let's just look at this really quick. I'm going to say if the attack is HTTP attack, I need to make sure that it's the right case, and that's why I do it here to my actual variable that I'm going to be checking. And this is just where I check to make sure that it matches what it's supposed to be. I suspect that for arguments, there may be capabilities, or maybe there's something on this argument parser that will allow you to specify the values in order to do check for whether valid input was entered. But I don't know what that is, so that's why I have this down here. Anyway, here is my code. Let's look at the main code right here. What I'm going to do is I'm going to set up my targets. So let's take a look at this. This looks a little bit different to you, and if you're not comfortable with some of the things that we do in Python, then you may want to look at this just to understand what's going on. It's a little bit quirky. It's not like things that we've done before. You're looking at this and you're saying, I see the square brackets and a for loop inside. That's telling me that it is a list comprehension. So this is a list comprehension. Now, what I'm doing is I am saying for, and this is where we normally put a variable name, but in fact, I don't care about the variable name. So I'm going to do a for loop. I'm not caring about the variable name. I do care about how many times I go through this loop. So I'm using the range function to go from 0 to the thread pool size. So if you have 50, your pool size is 50, then it will do it 50 times. If it's 200, it will do it 200 times. If it is 1, it will do it only 1 time. And what is it doing? It is basically going to, what data is it putting into this list? Well, the data that it's putting in is just a variable. I'm not even taking my variable from this actual for loop. So this is kind of weird. It's not the normal way that you will need to be doing things, or where you will be doing things in your list comprehensions in kind of real world situations. But what I wanted was a list with a repeated number of this value, which is the target. Why do I want that? I want that because remember my thread pool executor, I'm doing executor.map, and what I pass in is the actual name of the function that is going to get called, and then I pass in a list of the parameters that are going to get passed to it one at a time. So when I've done this before, I would pass in a list of devices, and my actual function, this is called HTTP request. In previous situations, you can see here it's going to be taking a parameter called the URL. And so in other situations, I would be passing in a device, and it would be different every time it would run. In this situation, and this is why I just want to take a little moment here, in this situation, all of the targets are exactly the same, and I'm basically going to create, let's say, my number of threads, my thread pool size was 50. I'm going to create 50 threads using this code to run it, and using, each one is going to use one of these items from the list. What are the items? Well, they're all the same thing, and they are the target. So I'm creating 50 of these threads, or 200 of these threads, and passing in this list of targets to executor.map. Every time HTTP request thread gets created, it's going to pass in the target, which is going to be the URL. And down here in my main, I'm doing this. If it's HTTP attack, then my executor.map is using HTTP request. If my attack is Icmp, then the function that I'm passing in is going to be ping host, and you can see ping host is right here. Again, it's getting a parameter, and which is going to be the target, which will be IP addresses in this situation. And that's all this does. This with statement creates them. If you need to know about threading, then look at the lessons or review what we've done in previous lessons on using thread pools. I go into it in a great amount of detail. I have this else clause right here. I should never get there because if it's not HTTP attack or Icmp attack, then I should have checked it right here, and if it wasn't, then I exited. All right, let's look at the functions that it calls. Here is HTTP request. What does it do? Let's forget about terminate for the minute. Basically, what we're going to do is we're going to do a while loop, and we're basically doing while true. So we're going to loop forever until we're told to terminate. And what are we doing? We are just doing request.get. That's all that we're doing. This is our denial of service code right here. The trick is that we are doing 50 or 200 of them, or however many threads you have created. That's how many we are doing all over and over and over and over and over again. All right, so that is the code that is actually causing the HTTP request to go out. If you need to review this, if you haven't gone through all the other lessons, I've gone through requests. We've done it many times, so you can refresh yourself on that. All I do next is print out the appropriate statement that says it was either successful or it failed. And if you do have a delay, then I will wait some number of seconds. If not, then we will just continue and do this over and over again. Ping host is essentially the same thing, another while true loop. And basically we've gotten the IP address. I'm doing this now. I do this in Quacka. I've done this in 52 weeks of Python when we did the host monitor. I'm calling subprocess, and I'm calling the method within it check output. And here are the things that I am calling. Basically, this becomes a command line thing. I'm doing a ping. I'm doing a count of 3, -n, -i, -w2. Can't even remember exactly what all of those are. If you want to know more about these, you can look at the ping command, or you can look at the code where I did host monitor way back when we were creating our quokka-prime application. So we run this, and if it fails, then we pop down to here and we print out that the ping failed, and if it's successful, we print that out again. If there's a delay, we delay, otherwise we continue on. So that is all that the denial of service stuff is. Really simple, just a handful of lines of code in order to do that. Now, the one thing that's of a little bit more interest is this terminate. So basically, I want to be able to have a keyboard interrupt, which causes me to cause all of my threads to terminate. So basically, I have a global variable called terminate, and when I say terminate equals true, because this is my global terminate variable, and because I've declared terminate to be a global variable in here, then every time I iterate through my while loop, I am going to check not only if it's true and I haven't been asked to terminate. If I have been asked to terminate, then I will end up terminating and ending this thread. And then at the end of that, all of these threads down here will be done, and we will just exit in the normal way. So that is the code. That's all that there is to it. If you wanted to add other stuff, you certainly could. I toyed with the idea of adding an attack to be one of the many SCAPI attacks that you can do. If you use if you want to use the SCAPI library. Those are more intense attacks, denial of service attacks. You can read all about it at the SCAPI website. Other people who have implemented it. There are plenty of places on the web that can show you how to do that. So you're welcome to do that. As we said at the beginning, the purpose here is to get you familiar with Python. And one of my goals would be that if you get to a point where your boss says, gee, wouldn't it be nice if, say, we could test our product by its resiliency and its ability to thwart attacks, etc., then you could say, hey, I know how to do that because I am not just a Python script coder from websites, but I actually can write Python code, and I'm even a software developer. So that's my goal. Hopefully this makes sense. I think what I'll do next is I'll show you me running it just so you can see it. You may have seen the scenarios. I haven't decided if I'm going to put this first or last after them, but you may have seen them, but I'll just go through running it in a little bit more detail. Okay, so here we are. I'm going to be running my dos.py denial of service attack. I'm passing in as a target is when I'm doing HTTP, I need to pass in the entire URL. So that's the URL that I am actually making a request for. I'm getting all the hosts back. My attack type is going to be HTTP. And my pool size, I'm going to actually change that so that it is only 10. So I'm going to go ahead and run this, and you can see it's doing its pings over and over again, as you will be able to see up here. I'm actually hitting my own system pretty hard. Remember, this system only has a couple of cores. I'm using 10 different threads in order to do this. You can see it's up there around 80 most of the time. And my other system, I can tell you because I'm looking at it right now, while it is getting hit with a ton of requests, it's actually handling it quite well. In fact, it's not even hindered in the least. The CPU utilization is still quite high. So how do I get this to stop? I'm going to do a Control C. My Control C caused my application to set the terminated value, this terminate right here, and then all the threads eventually, as they were going through, ended up terminating themselves, and I ended up with a clean shutdown, and there we see. So you can play with this. I'm gonna, if I were to set my pool size to 1, that means I would do this only with the one thread, and I really should have a rate to figure out what the rate is that I'm getting in terms of the number of requests, but I'm sure it's much lower because I am spending a lot of time waiting. And in fact, you can see, I think you can see that the CPU utilization is a little bit less. It's maybe 20% less than it was. Not sure what conclusions we can draw from that, but there you go. I'm going to do Control C to shut it down. I suspect if I was to set this really high, like let me set it to 400, so it's going to try to start 400 threads. I'm not even sure I can start 400 threads on this system, but I guess we'll find out if I can or not. It is doing all of my requests. I'm looking over at the other system, and again, there's not a whole lot going on. I think probably I hit a maximum with a certain number of threads, and then I begin to just thrash. I suspect that what's happening is my operating system is thrashing pretty hard as it tries to swap between all these different threads, and I'm not really getting a lot more. I think you can see that it's bigger than it was, certainly with one thread, but it's I'm not able to achieve a whole lot more. Again, you could set, you could get a count going for how many requests per second or per minute, and that would tell you something about the rate at which you're able to hammer the other system. But I can tell you it's not really having any impact on the other system, even though I have 400 of these threads going. I think one thing that you'll see, well, it did terminate pretty happily and quickly there. So if I was to just scroll up, you can see I'm scrolling up, scrolling up, scrolling up, still scrolling, still scrolling, still scrolling. I'm going to eventually get to 400 of these. I'm not actually counting them. In fact, it's taking me, there we go. So you can see there's a whole lot of threads that had to be terminated eventually. My finger is getting tired from using the the scroll mousey thing. Anyway, hopefully that gives you an idea of how you actually run this program. So you may be asking the question, is there anything that can be done to prohibit or limit the effects of a denial of service attack? And the answer is, in the larger scope, yes, there are plenty of big front-end applications. You can imagine that Google and Facebook and Twitter and all those folks have lots of not only load balancers, but also firewalls and denial of service attack detectors and throttlers. And so for our little application, our quokka-prime, is there anything that we could do in a similar vein to keep people from annoying our application? And the answer is yes. And I found something in the Flask environment, the Flask universe, that will do just that. And it's called Flask_limiter. And so I just looked this up, found out about it. Basically, the idea of Flask limiter is that you can limit the number of requests that come in by default from a remote address. And so what do you have to do in order to make that happen? Well, the first thing you need to do is you need to import Flask limiter. So you import limiter from there, and from flasklimiter.util you import get remote address. And then what you do from that point forward is you need to create this thing called a limiter. So you create your limiter and you pass in the name of your application. The name of my application is called Quacka app. And then you pass in this thing called a key function. That is what the limiter will use when it is determining who to limit. In other words, it doesn't just do a blanket limit of a certain number of requests. It does it on a per user standpoint. And so we're using the remote address as the ability to distinguish users. That's what the default is. So now that I've set this up, how do I set what the limit is? Well, the first thing, let me tell you, if you are attempting to use their default simple way to do it, it won't work. And the reason it won't work is because we are using this class-based definition. Remember, we started defining just functions for our endpoints, and that was the simpler way to do things. When we went to Swagger, we needed to use this class method of defining our endpoints with different methods for get and for put, etc. And so when we did that, we made life a little bit more difficult when it came to setting up things like limiters. And so what I ended up having to do when I found out that it didn't work, I had to begin doing Google searches. And sure enough, I found out that there was a way to fix it. And here's the text that I found. Actually, I found it elsewhere, and it pointed me to this. If you're using a class-based approach to defining view functions, which we are, the regular method of decorating a view function to apply a per route rate limit will not work. And so they give you the simple way to do that, which is basically, this is basically what I have done. And you do need to look at the documentation to understand how you set the rate limits. You can do a number slash and then the unit. And I think what I have done is 60 per minute. And you can see I've commented it out for our original stuff that we were running. So I'm going to hit Control / and that gets rid of that. So now what I'm going to do is I'm going to go over here and I'm going to run Quacka. So here I am running Quacka with rate limiting on. So on my other laptop, I'm not going to show this to you because it's a hassle for me to do, but take my word for it. You've seen me do this before. I'm going to do an attack, an HTTP attack. And what we're going to see is the following. I'm doing my HTTP attack, and let me stop this and go back and show you. Do you see all these that happened at the beginning? At the beginning, I have a number of these that are successful, and then, and by successful, I mean the response is a 200 here. Do you see this right here? The 200 says that it was successful. When I scroll down a little bit, you'll see that I start returning 429. 429 basically says you've done too many requests and you are now getting rejected. And so that is what is going on in this situation. You can see I keep printing these out over and over and over again. Now, let's look over here at my CPU utilization. You can see that my CPU utilization is indeed quite high. If you look down here, and we just lost it, but my network traffic is a lot lower than it was. It used to be at a particular value and now it's much lower, but my CPU utilization is still pretty high. And you may say, well, what's the value of this? It's still hammering my CPU. And that is indeed true, but think about this. And I'm just gonna kind of wave my hands here. I need you to pause and think about this. Think about our quokka-prime application. What does it have? It has this server functionality. It has an entire database behind it. And if these requests were getting through, I would be hammering not only my database, but also any business logic, any filtering I would be doing. All of the stuff that's going on at the back end would be getting hammered. As it is, I'm basically, my HTTP server, my web server that is part of Flask is having to deal with all of these requests, but they are getting thrown back in the face of the requester immediately without getting into our application at all. So this is really doing a lot of good. I know when you look here and you see this is pretty high, pretty high CPU utilization. That is true. And if you were doing a real world service, then you would have something that was actually a full-blown throttling of this so that it didn't even get to your application. It would be rejecting things at the front end in front of this request. Front end meaning the thing that goes in front of your server. And so, when I initially ran this, I thought, wait a minute, this isn't really doing any good. But actually, it is doing good. It's saving all of my back-end code from having to run, so I'm not having to do any of that. Why is the CPU utilization still really high? The reason is I'm rejecting these requests so fast that my application that I'm looking at running on my other laptop is able to send these requests in at a much higher rate, interestingly. So whereas before, because I was getting the stuff from the database and sending a legitimate reply, I'm probably getting these responses going back to the caller at a fraction of the rate of what it was when I was actually returning the data. The rate would be much slower in terms of the number of these responses that are going back. But now in this situation, we're actually able to respond much quicker. And in fact, you can see every minute, here's some more 200s that I just saw go by. So, all right, so that is basically what you can do in order to set up rate limits. And you'd probably want to do something like this just to protect your application and your database from getting hammered. Okay, let's review what we talked about in this lesson, shall we? We talked about how, since I wanted to use two different systems to run this denial of service code that I had created, that it would be useful to store it in Git, which I do anyway, and then I showed how to save things to Git, and then on the other system how to pull it down, and I'm up and running immediately on my other system with the new code. And so we showed how to use Git to do that. The code that I wrote is an application that takes parameters, that tells it what to do. Once it knows what it needs to do, it creates a certain number of threads, and using those threads passes them the target, and those threads then attack the target. And you can use this either for doing some type of denial of service, was probably not recommended, but if you wanted to do stress testing, etc., that would be a useful application of this code. The main thing, remember, of what we learned It's we want to become software developers and we want to learn Python. And so learning about doing multi-threading and getting parameters. And actually, we even looked at using rate limiting in our quokka-prime application in order to keep people from attacking our service. So that's what we went over. Hopefully it made sense and you know a little bit more about Git, about concurrency and using threads, and about limiting requests coming in to Flask. If you have any questions, please let me know. Thanks for listening.